2,000 years ago, a magnetite was discovered in China. A compass made by these magnets became a guide to the world, opening the age of exploration. In the 19th century in Europe, electromagnetic force was found. When a current flows through a wire, the magnetic line of force is created in the direction that the right-hand screw rotates. In 1837, in the United States, Samuel Morse developed a telegraph repeater using electromagnetic waves, and this opened the era of telecommunication that made possible to communicate from long distances and different time zones. In the 21st century, the South Korea's KTM is opening the era of the space exploration with a magnetism controlling technology. Currently, most of the lifting or holding devices are operated using electronic magnetism. However, this system has the disadvantage: it has to continuously consume electricity when holding objects. This is the lifting system using an electromagnet. A steady current supply is needed to lift a passenger car. An uninterruptible supply system is needed for loss of power that happens frequently. An air conditioning unit is needed to prevent from electromagnetic force decrease, as with increase in temperature over time. Lastly, residual remover device is needed to remove residual force of electromagnetic force. When lifting a minibus, which is 2 times heavier than passenger car, 2 times larger current supplies, UPS, residual removal apparatus and air conditioning units are required, and when lifting heavier trucks, which are 5 times heavier than passenger cars, current systems requires higher cost with inefficient structures, but because there were no alternatives, they are still widely used. Here is the world's first magnetism controlling technology developed by KTM. This technology uses magnetic power of permanent magnets, and permanently attach and detach objects without additional devices. In order to control this, only a small amount of current is required, and this technology no longer requires none of high-capacity supply units, UPS, air conditioning systems, residual removal devices, and so on. Therefore, it can be used as an innovative core technology in many fields such as automation industry, mechanical industry, automobile industry, shipbuilding industry, logistics industry, and aerospace industry. This is a permanent magnet with N and S poles. Magnetic substance A is attached at bottom side of this magnet. Generally, people think that magnetic substance B will be attached to this magnet, but they are not. A magnetic substance A connected to a permanent magnet forms a root of magnet field, and the magnetic substance approaching the magnet cannot form the path of the magnetic field, due to previously formed root of magnet field. Therefore, magnetic B is not attached to magnets. The technique of using this principle is magnetism controlling technology developed by KTM. When attempting to attach, hold, and detach magnetic substance A made of iron, if a permanent magnet first builds its path to magnetic substance B, magnetic substance A cannot be attached to a permanent magnet. Once the temporary DC current is supplied, forming the N poles of an electromagnet in the N magnetic field of the permanent magnet, the magnetic substance A is attached to the permanent magnet. Even when electric power is not supplied, magnetic substance A keep attached to the permanent magnet. In contrast, if the DC current is temporarily supplied to an electromagnet forming S poles, then the magnetic substance A will fall off the magnet. KTM's magnetism controlling technology is a work-holding technology that consumes a small amount of DC current, less than 1 second, to attach or detach objects. In particular, this technology has a stronger capability than conventional electromagnetic technology to hold objects when they are separated by, for instance, 0.4 millimeters. It is also possible to hold even dozens of tons of heavy objects when this technology is applied with clamping devices. KTM technology can be applied as portable holding devices because it consumes a small amount of DC current in an instant. Also, this technology has advantages in terms of reliability and manufacturing costs.
KTM 자기 제어 기술은 전력 소모가 거의 없이 크린 작업장을 제공하는 미래형 원천 기술로서 많은 산업에 폭넓게 보급할 수 있어 국내 기업 경쟁력 제고와 기술 수출에 기여할 것입니다. 또한 조만간 기후변화에 대응한 혁신적인 신자기에너지 원천 기술, 즉 크린, 포타블, 로코스트 자기에너지를 연구 개발하여 인류 사회에 공헌하고자 합니다.